student at Central University of Technology doing BEng Tech in Electrical Engineering. Currently, I'm doing Projects 3, which is one of the modules under the BEng Tech for a final year student. This is the project that I have designed all by myself, from the enclosure, joining the components together, and I present to you guys my smart home automation system. So I will take you through the process, how I've came up to this final product. You can also see here, here I'm having my proposal. So the problem statement, many household faces challenges in managing, controlling various devices such as lights because of manual operation that can be time consuming and inconvenient. So I decided to design this automated system that will work to enhance the convenience, energy saving, also security purposes. I'll break it down so that you'll understand, especially for some like security purposes. First of all, here I'm having 3 sensors: LDR, DHT11, and lastly I'm having PIR. So here it is the LDR. The LDR, it is a sensor that detects the light levels. So when it's dark, it will turn the bulb on, and when there's a sufficient light, meaning maybe during the broad day, it will turn the light off. Also, let me remove my roof. I've designed that portable roof so that I'm able to deal with the connection. Let me take you through the process. Here is my connection of everything. Here I'm having the breadboard. Here I'm having a relay module. I'm also having other relay module this side. This one, a relay module, works in hand with the fan, and the other relay module works in hand with the bulb. So here's the sensor that I was talking about that I wanted to show you guys. It is a DHT11. So one will say it is a temperature sensor. So the temperature sensor will work in place of, it monitors the temperature control. So in this case, I've used room temperature, for instance. And lastly, here's the sensor that I have there. It's PIR. So PIR is the one which goes to the security purposes I've mentioned earlier. It detects motion. So when there's motion, it will trigger a buzzer. Also, I have a buzzer here. It will trigger a buzzer to make sound. When there's no motion, the buzzer would be off. So going back to that DHT temperature sensor, in short, so when the temperature is above room temperature level, it will turn on the fan so that it cools down. So basically, that's the operation of my project. Lastly, I'm having here a LCD. So this LCD shows everything, how everything should work. It shows the temperature, it also shows the motion. So here I'm having a block diagram. It has got like the inputs. Also, it has got the outputs with the cloud server. The cloud server would collect data from the sensors via the Wi-Fi module, which is ESP01. So here I'm having a schematic. So this schematic shows these sensors and components that I've connected here. I'm having the PR sensor, I'm having the DHT that I talked about, I'm having the LCD, I'm having the Arduino, I'm having the relay module, I'm having a fan. In case you didn't see my Arduino, here is it. I've even made a small hole to accommodate the cable from the laptop. So here I'm having the PCB, which shows the lines, how and everything is connected. So let me take you through the process of everything. I'll start with the temperature sensor and show you how it works. So the temperature sensor here will sense the room temperature. So if ever it is above 25 degrees Celsius, which is, in my case, is the room temperature, it should cool down the place. So at this moment, the fan is at stationary, it's not moving. So I will increase the room temperature and you see by the fan whether it is gonna move. And let me also show you currently there. Here is it, it's 23 degrees Celsius. Let's see when I increase the room temperature. I'm increasing the room temperature by placing some heat near the DHT11 sensor. And I'm expecting the temperatures to go high. And when they go above 25 degrees Celsius, the fan should be activated or triggered to cool down the environment. It's coming. The temperatures are currently increasing slowly but surely. Now it's on 24. From 23 it's on 24 degrees Celsius. Looking for something above 25 degrees Celsius. Here is it. I'm having something above the 25 degrees and the fan has been activated. Here's the current reading from the LCD. It is above the 25 degrees. I've talked about the fan spinning. It's cooling down the place. So basically, that's how we expect the world of automation to work. You don't have to go manually and do it. It saves time, it saves energy, it also saves, it's convenient to be used, especially in this 4IR time. So now we're moving to the LDR. I've placed the LDR outside because of if ever I placed it inside with the roof, there's a shade in this house enclosure brackets that I have here. So like I mentioned, the operation of LDR. Let's see, or additionally, I'm having a servo motor here, I'm having a servo motor. A servo motor will, when it's at night, it should, here's the servo motor. When it's at night, it should close the curtains. So in my case, here's the curtain. Placed it front of the windows that I have. So here's the curtain. The servo motor should close the curtains at night. During the day or in the morning, it should open the curtains. So it is linked to the LDR sensor. So let's see how the LDR sensor works. You see, I've put like a shade here, meaning now it can sense that it's at night, or there's a low light level, and it puts the bulb on. So let's practically see what I was talking about. Since I said the servo motor is linked with the LDR. So here's the servo motor. So when I place here, you see the servo motor is moving in 90 degrees, from 0 degrees to 90 degrees. So lastly, let's go to the PIR sensor. Let me show you what is currently being read from the LCD. There's no motion. Now I would expect someone to walk towards the door. You see the buzzer is activated, is making sound. When someone is walking and you've set maybe your alarm, motion activated, motion detected. So the motion is detected. So I'm having this PIR, which will act as a security in this case. So here I'm having a flow chart that it shows how every process that works. We also have got the components, the sensors that I have from the start of the process, from the start of this operation up until the end, with the help of a code, definitely, which is part of the software. As here I'm having a hardware. So this is the enclosure that I have. So here it's I would say it's a garage. That's why I've placed it here. It's outside. The LDR sensors will work with this one. And also I want to mention, and here I'm having this 12 volts battery. So basically I needed to supply this fan. This fan is rated 12 volts, and my Arduino can only supply the 5 volt. So I needed to step it up, and having this 12 volt battery, so it's connected. But then now I had to use 2 relay modules so that these 2 can work separately. These 2 meaning the fan and the bulb. So basically that's the project that I'm having right now. I wanted to show you to present to you the operation of servo motor. I know that I've shown its movement, but then I wanted to show a bit how it is gonna work on this case. Basically, okay, okay. So basically now let's put like some shade on the LDR. You see the curtains have opened with the help of our servo motor. So thank you guys. This is the final project with the roof, obvious. So yeah, thank you guys.